Okay, so chapter 8, loop structures and booleans, page 233. For loops, a quick review, and 234. But let's go through. They got a little bit of pseudocode here on 234. Input the counter numbers n and initialize the sum to 0. Loop n times, indent, input a number x, add x to sum, and then the output averages sum. That's indented out. As either a print statement or a return, but the output makes it clear that it's going to be a print statement. So let's do average1.py. Let's do exactly what they're doing on this page, and let's just go over exactly. Let's go over exactly what it does. So page 234, Zelle, chapter 8, body. Second edition, intro to CS, and this is Python 3. All right, so let's do. All right, so this is going to be main, and it's going to be eval input. How many numbers do you have? Sum. It's going to be 0.0 for I in range of n. So 0 to n minus 1, because that n is not inclusive. X gets eval. So we're going to have a whole bunch of these statements, or these prompts rather. Enter a number, the two chevrons here. Space there. I think they're called chevrons. I don't know if it's because they. I think it'd still be called a chevron if they aimed right, but or if they aimed left. But all right, sum gets sum plus x, and then we'll do print the average of the numbers is sum slash n, and then main. So how many numbers do you have? Sum is going to be 0.0, so we know we're going to, it's going to be a float, right, instead of an int. It would still create a float as well. I think if we divided, if we kept conflating those, I still think it would. But let's run it. We could even test it. I mean, it's going to be pretty obvious, but I mean, I think this makes it pretty clear that it's going to be a float that we're looking for. So, but if you do 45 plus 45 plus 76 plus 21 plus 22, and then divide by 5. Oh, 209 divided by 5. Yeah, you're going to get that, but I like that. It just makes it pretty clear. Okay, so let's check it out. It's going to be average 2. All right, let's check it out. Okay, we have 9 numbers. 12, 11, negative 8, negative 98, 121, 74, 32, negative 12, negative 5. All right. 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So you get our 9 numbers, 0 through 8, which is just, 9 times, essentially, for I range of n. And then x is going to be our eval, and then we're just going to add them all up. And then sum divided by n is 14. All right, cool. Nothing too crazy. Okay, so now 8.2 indefinite loops, Ch8 while loops. We could use for loops. I like for loops. Look how much shorter they are. On like 236, you initialize I gets 0, and then while I is less than or equal to 10, print I, and then I gets I plus 1. I just think for loops, it just looks so much cleaner. But yeah, I mean, there are definitely benefits to while loops. The simplicity of the while statement makes it look powerful and dangerous because it is less rigid, it is more versatile, it can do more than just iterate through sequences, but it's also a common source of errors, which I've seen, being, especially early on when I just started, like while loops. That's just a good spot to and colleagues of mine as well, just to do unlimited or just indefinite loops, just go on forever. So, and that's what they're talking about. So, infinite loops. Yeah, 8.3 common loop patterns, interactive loops. So then we've got the general pattern on 238. And we've got the algorithm, initialize sum to 0.0, initialize count to 0, set more data to yes, etc. So we could do that. We could change that up a little bit. Change this program up a little bit. So let's call it average 2. Well, this is going to be called average 3 because I think I already had another average problem. Average pi problem. All right. So this is page 238, Zelle, intro to CS, Python 3, second edition. And then I know I'm supposed to put, Microsoft. All right, then we can explain like what it does. But right now, let's just go through the program. All right, so sum gets 0.0, count gets 0, more data gets yes. So while more data at 0 equals y. So the 0, yeah, which is cool because it saves us if we type in yes, and you see that on 239 if you type in the word yes or just y. Let's fix it for capital also. So let's just do y is going to be y, right? And then let's do y dot lower. It actually doesn't do it. It makes it lower. Doesn't really help us though. Doesn't help us at all. I think it actually confuses it. So you could say y or more data at 0 is going to be y if someone does capital. All right, so let's do that. And then x gets eval input. Enter a number. And then our chevrons here. And then sum gets sum plus x. And then count gets count plus 1. More data. Is going to get input. loops is sum slash count. And then we're going to invoke main. Enter a number. Yeah. 23, yep. 9, yes. 6, yes. And then boom. So then it just kicks us out. So that helps us. Well, n is not defined. Oh, because I didn't punch in the number. Yeah, I ran that wrong. So let's run it again. And then 12, and then nope. 15. So 21 plus 24 is 45 divided by 3 is 15.0 exactly. So yeah, we sort of helped it out too. Because if you had capital, I really like this. I really like this a lot. I like this indexing. This is, every time I read, this is another reason why I love, like learning from, just in general, from any source, that, who's author or who's, progenitor of the material has obviously done their work. That you're gonna learn stuff, and this is pretty cool. Just indexing, saying, look, people are gonna misspell things, they're gonna capitalize, but you want to keep them in. You don't always have to use try, except, you can just say, look, at index 0, as long as it's lowercase y or uppercase y, then continue, because you know that they probably meant yes, but yeah. All right, so we'll see you guys in the next video. If you're interested in checking out more about loops, sentinel loops, etc. on chapter 8. Thank you very much.